Hey everybody, welcome back to Chapter 4, Section 3. In this video, we are going to be solving quadratic equations by completing the square when the a coefficient is not equal to 1. So fortunately, if a is not equal to 1, there's not going to be anything too special with it. Just simply divide everything by that a value and then proceed like any other completing the square problem. So this first example here, I'm going to need to divide everything by 4. So when you divide out a number, you want to make sure you do it to everything on the left side and everything on the right side as well. It was equal to 0, so 0 divided by 4 isn't going to change this value, but it's the principle of the matter that the rules of algebra dictate that what you do to one side, you must do to the other. So dividing 4 by everything will get me x squared plus 8x plus 17 equals 0. So now I'll proceed like I was doing the completing the square problems when a equals 1 in the previous video. So I need to minus the 17 over to the other side, and then I need to add in that b over 2 squared value to both sides. So my b value is 8. Remember, the b is always the value that's by the x. Don't include the x though. So I'm just going to take 8, divide it by 2, and square it, and add it in on both sides. So 8 divided by 2 is 4, and 4 squared is 16. So what I'm doing is I'm adding 16 to both sides. So on the right hand side, that's pretty simple. You just need to combine those two numbers. Negative 17 plus 16 is negative 1. And then the right hand side, you need to factor. Remember, it's called completing the square because you're turning this into a perfect square trinomial. So that means the factors of 16 that add up to 8 are going to be the same number, which is 4 and 4. And so you write x plus 4 times x plus 4. But since it's the same thing twice, you can just write x plus 4 squared. And then in the previous video, I also explained you can think of it like this. Since it's a perfect square trinomial, the factors, the square root of the last number will add up to get the middle number. The square root of 16 is plus or minus 4. I'll use a positive 4 since it was a positive 8x in the middle. So positive 4 plus positive 4 is 8. Positive 4 times positive 4 is 16. And then the kind of cheat, quote unquote, is to just look at this step right here and look at the b over 2 value. 8 over 2 is a positive 4. So this number is actually going to always be this number here in the factored form. So 8 over 2 is positive 4. It says x plus 4 squared. All right? So however you want to think about it is how I want you to do it. But from this step here, you need to square root both sides because we got to get rid of this power of 2 before we can minus this 4 over. So I'm going to square root both sides, and that's just going to leave behind the x plus 4. And then the square root of negative 1, if you'll recall, is just the letter I. By definition, the square root of negative 1 is I. And don't forget to write your plus or minus by it. Now, I think some kids might make the mistake of saying the square root of negative 1 is I, or plus or minus I square root 1. But the square root of 1 is 1. And so then you just be writing plus or minus, you might as well write plus or minus 1i. And then you don't need to write a 1 for a coefficient when it's by any letter. So then effectively, you're just writing plus or minus I. So that's basically why the square root of negative 1 is just the letter I. So once you get to this step, all you need to do is add or subtract the number that's by the x to the other side, and then put it in front of the plus or minus term. So I'm going to write x equals negative 4 plus or minus I. And that's actually going to be your final answer, because I can't simplify that beyond that other than maybe writing negative 4 plus I and negative 4 minus I. But other than that, that's going to be the final answer. So just to kind of reiterate my point, if you look at the graph of the very original equation, just don't type in the equals 0, you'll notice that the parabola never touches the x-axis. Therefore, it has no real roots, but you can say it has two imaginary roots, the imaginary roots being negative 4 plus I and negative 4 minus I. Moving on to my next example, I see there is a negative 3 in front, so I'm going to divide everything by negative 3. And remember, what you do to one side, you must do to the other. So we're dividing a 0 by negative 3, so it's still going to equal 0. So that's just going to leave behind x squared. This will make plus 6x. This will make plus 2, and it's equal to 0 now. So what you want to do, move your c term over to the other side, and then add in your b over 2 squared term to both sides. So my b term here is 6. So I'm going to add in 6 over 2 squared to both sides. And 6 divided by 2 is 3, and 3 squared is 9, so I'm adding in 9 to both sides. Once you do that, you can just combine the two terms on the right. Negative 2 plus 9 is 7, and then factor the terms on the left. X squared plus 6x plus 9. What are the factors of 9 that add up to 6? That's 3 and 3. So you're going to write down x plus 3 squared. And remember, the quote-unquote cheat is to look at the b over 2 number before you square it. 6 over 2 is 3. That's a positive 3, so I'm going to write x plus 3 squared. So if you ever want to just think about it like that, feel free to do so. But once you get to this step, now you can square root both sides to get rid of that power of 2. And so we're square rooting a positive 7, so we're not going to have an I term. We're just going to have x plus 3 equals plus or minus the square root of 7. The reason why I didn't simplify the square root of 7 is because it can't. It's a prime number, so the only factors of 7 are 7 and 1. And if you type in the square root of 7, you get this decimal that goes on forever. So I'd rather not write that or round that. I'd rather just keep it as plus or minus the square root of 7 until I get my final answer. I'm okay with you rounding your final answer, but don't round. If you don't have to, don't round until the very, very end. So for my final step, I will just minus 3 to the other side, and I have x equals negative 3 plus or minus the square root of 7. So if your teacher asks you to give you the rounded answers, you just need to type into your scientific calculator negative 3 plus the square root of 7 and negative 3 minus the square root of 7. And so for me, I like to ask my students to round to the nearest thousandths place. So this would be negative 0.354, and then look at the 2 that doesn't round it up. So I'd say negative 0.354. And then the other one, I'd say negative 5.646, because that 7 is going to round that 5 up to a 6. And also, if you type it into the graph, you just type in the original equation without the equals 0 part. Just look at the x-intercept since this has real roots. These are the answers in rounded form to the nearest thousandths place, so that's kind of nice too. So for my final example here, I see a 2 in front, so I'm going to divide everything by 2. And then you'll notice it's going to give me a fraction in the middle. Negative 11 over 2 can make negative 5.5, but I prefer you keep things as a fraction. And here's why. If you keep it as a fraction, you have the exact answer the whole way through. So what I mean by that is 11 over 2 is 5.5. That's a friendly fraction, if you ask me. But let's say if it was 11 over 3, that would be 3.3 forever, and you'd have this continuing decimals. So whenever you have fractions with long decimals or continuing decimals, I don't want you to write those. I don't want you to have to write all those decimals, or I don't want you to round it, because I want you to get the most accurate answer. So in order for you to get the most accurate answer is for you to keep things as a fraction until the very end. You might want to round your final answer, but don't round during like the first or second step, because then it's just going to get farther and farther away from the correct answer. When you have fractions in your equation, just really try and proceed as normal, because there's really not going to be anything special about the answer other than it's going to have fractions in it. So I'm going to add 6 to the other side, and then I need to add in my b over 2 squared value. So that's going to give me a negative 11 over 2 over 2 again, because you still have to divide it by 2. This one's kind of confusing because the fraction was already over 2. So whatever this number is, make sure you divide it by 2. So in this case, I have it divided by 2 twice. It's not going to happen every time you have a fraction, just whenever you have a fraction that's over 2. Anyway, so add that to both sides. And so this looks very confusing probably to most people, but whenever you are dividing a fraction by a number, all you got to do is really just multiply the two bottom numbers together. So 2 times 2 are my two bottom numbers. So that's negative 11 over 4 then. So that's all you got to write down. That's before you square it, of course. but that's basically what that number is. And so then I'll just write equals 6 plus 11 over 4 squared to the other side as well. Sorry, negative 11 over 4. Of course, you could also use a scientific calculator app like the Algebra scientific calculator app or the Desmos scientific calculator app, and those apps will actually give you the answer in fraction form or decimal form. So this one is the answer in fraction form, so you could just type it in and use the calculator still if you need to. But like I said, all you really need to do is just multiply those two bottom numbers together. So now to square it, you can use the calculator again or just square the top number and square the bottom number individually. 11 squared is 121, 4 squared is 16, and then when you square a negative, it turns into positive. So I'm going to add in plus 121 over 16 to both sides. So when it gets to trying to factor the perfect square trinomial on the left, it can look very daunting because you have a fraction here and a fraction there. But remember, the quote-unquote cheat I talked about earlier is you can just say x plus or minus the number that's in the parentheses in the step before. So your b over 2 number is negative 11 over 4. So I'm just going to say x minus 11 over 4 squared. And now I've factored this trinomial right there. And then this one is 6 plus 121 over 16. So we're going to have to do some least common denominator work. So when you are adding a whole number to a fraction, you want to make sure that whole number is also a fraction. So it needs to have a denominator of 16, because whenever you add or subtract fractions, they need to have the same denominator. So it's actually pretty simple. All you have to do is do 6 times 16 over 16. And the reason why it's 16 over 16 is because, well, this is the base, or the denominator, and so you have to put it over itself because anything divided by itself is 1. So really all you're doing is 6 times 1 if you think about it. But this will convert it to a fraction. This will convert it to 96 over 16. And if you were to type that into a calculator, 96 divided by 16, you'll get 6. So that's how you know you did it right. But basically, you are able to add it to 121 over 16 now. And so all you got to do is keep your bottom number the same and add together the tops. So that's going to make 217 over 16. And again, if that feels like it's too much, use, the Desmos scientific calculator app or the GeoGebra one. Just type it in and it'll give you the answer in fraction form. So from this step here, all we need to do is square root both sides. And so when you're square rooting the left-hand side, that's just going to leave behind x minus 11 over 4. And then the right-hand side will be plus or minus. Don't worry about trying to simplify the square root of 217 over 16, really. You don't have to get it to a decimal form just yet. But the square root of 217, I don't think it simplifies, and I'm not going to try. But the square root of 16, because when you're taking the square root of a fraction, you're doing the square root of the top and the bottom. So the square root of 16 can't square root. That's 4. So I can rewrite the fraction at least like this. And then all I have to do now is just add 11 over 4 to both sides to get my final answer. So after you add the 11 over 4 to the other side, your teacher might accept this for your final answer. But if they ask you to give you the answer in the rounded form, just type it into a scientific calculator. So here it is typed into a scientific calculator. Remember, you have to do it, since it was a plus or minus sign in the middle, you have to do it once with the plus and once with the minus. And so I get 6.4327. So that 7 will round that 2 up to a 3. So it'll be 6.433. And then this one will be 9.9327. Again, that'll round that up to a 3. So it'll be negative 0.933. And of course, you could just graph it, and since the answers were real solutions, and here it is typed into Desmos, and you see it's already rounded to the nearest thousands place. So that's going to wrap up this video. Thank you for watching, and goodbye.